you'll have to go up to 800. And of course you split it and you go up in those nice steps. So my point is that sometimes this first plate could be anything. It might be 0 volts, it might be 500 volts, it could be negative 200 volts, whatever. But the rule that you follow is that you just use ED and you add those voltages on. So you would have 600, 700, 800. And the idea is you're always having a 300 volt difference between from here to here. Okay, same thing, here to here is 300. Okay. All right, one other thing I'll show you. It's nice to know sometimes what the charge density is on plates. Let's say I've got positive plates, negatives, negatives. They're equal and opposite. This is a pretty standard thing in electricity. So there's a sigma up here. It's positive. There's a negative sigma down here. And of course this creates an electric field between them. So, you know, how could you actually find the value of sigma, right? And sigma would be something in coulombs per square meter, right? How does someone actually go about getting that? And it's actually pretty easy. You have to measure two things. You have to measure, first of all, the voltage difference between the plates using a voltage meter. And secondly, you just have to know the distance between them. And then what you do is you basically use that delta V is equal to E times D. And you can pull over the D. Okay, so now you know what the electric field is, right? If you know what the voltage difference is and you divide by the distance, you can find the electric field. Okay, so these are easy to measure. And then how do you relate the electric field to sigma? You have to remember that we earlier in this class came up with the relationship that the electric field between parallel plates that are oppositely charged is given by that relationship. So that's how you can actually get this. You can solve for that sigma now, because you can measure a voltage difference, you can measure a distance, and you multiply by the epsilon. So that's a great way to do it. That shows up sometimes in AP questions and in other things. All right, so we've derived, we figured out some important stuff about the uniform fields. The most important idea is that we've met ED, and ED is the way that the electric potential changes as you travel either with or against a uniform electric field. So hopefully that was helpful.